Hello guys, in this video we will see how to work with the Word2Vec model supplied by Gensim library. Okay, we will see how to use the pre-trained Word2Vec model that is trained by Google, and also we will see how to train our own Word2Vec model with the purpose that we have with us. Okay, so let's get started. So in order to make use of the Word2Vec model, you need to first install Gensim, right? So how do you do that? You go to the command prompt, use pip install Gensim, right? So once you do this, you hit enter, and if it has not been installed, it will say it's installing, and once it is done, it says installation successful. Now that I have already installed it, it says requirement already satisfied, and I don't have to install it again, right? So now to make use of Gensim in code through Python, what we have to do? So I am importing from gensim.models, right? Import Word2Vec. Okay, so this is my Word2Vec model. Now, in order to make use of pre-trained model by Google, the Word2Vec model, we need to import another thing called as keyed vectors. Okay, so I'll import that as well. Now, where will you find the pre-trained Google Word2Vec model, right? So if you search in Google Word2Vec, the first link will take you there. Open that, and if you just scroll down a bit, you will see pre-trained word and phrase vectors, right? So you click on this, it will download, right? So I have already downloaded it. You see, it's a gzip file. You click on download, it's 1.5 GB, right? So I have already downloaded it in my system in the same path where I have my notebook, right? So I'll not be downloading it again. So I'll be just loading that trained model, right? So in order to do that, I'll say model is equal to, I'll say keyed vectors dot load Word2Vec format, and here I'll have to say, I'll have to give the name of the gzip file. You can directly supply the .gz format and it will take it. And binary, we'll have to set it to 2 because it's already trained model, right? It already has the vectors. And let me limit the word vectors to top 100,000 vectors. Okay, so 100,000, I'm limiting it. So this Google model is actually trained on 100 billion words, and for each word it is trained to have 300 dimensional vector space, right? So now I'm importing the trained model. So this will take some time based on your system capacity. Now it has been imported in my machine, right? So now our model is ready to use. Which is our model? It is the pre-trained Word2Vec model by Google. Okay, so what we can say, let's say model, if I want to check the vectors for word king, so I just have to subscript the model with the king. So this will be acting as a key, right? So if I do this, it will give me the 300 dimensional vector for the word king. So this you can see here. So for each dimension, you take it as a feature. Okay, so that's how you check the vectors. So suppose, for example, if I want to check the vectors for man, right? So you can do that same. So no matter which word you want to check the vectors, but it should be available in the vocabulary, right? So let's say if apple is there, yes, we have apple as well. Why I'm saying it has to be in the vocabulary when we are taking the pre-trained model? Because I'm limiting to first topmost 100,000 words, right? So that's the reason I just said whether it's present or not. But if you load everything, it will take more time. The model is huge, so you will have almost every word in the corpus. Okay, so this is how you check the vectors for each word, right? Now coming to the famous phrase, let's say model of king minus model of man plus model of woman, right? So this gives us a vector, and this will be very near to the word vector of word queen, right? So let me save this in a variable called vec, right? And then if I want to check the similar words for this vector, I can say model dot most similar. Then you have to give the vector. Okay. Most similar. It's by vector, right? So it should be similar by vector, right? Model dot similar by vector, and I will pass in this particular vector here. So if I give this, see, this vector is very near to king, queen, woman, kings, queens, princess, monarch, monarchy, crown prince, women's, right? So, and whatever numbers you are seeing here, these are all our cosine similarities. Okay. So like this, you can get the most similar words by words also. In this case, we have seen the most similar words by vectors, right? I supplied the vectors as input and it gave me the words as the nearest words as the output, right? So similarly, we can say most similar, and you can pass in the words. So let's say I want to check most similar words for the word man. If I execute it, it will say woman, boy, teenager, teenage girl, girl, robber, teenager, man, guy, person, right? So these are all the most similar words or the most nearest words to the word man, right? And this is the similarity score. So similarly, if you want to check the most similar words for any other words, you can do that. So let's say king, right? King. If I check it, the most similar words are kings, queen, monarch, crown prince, prince, sultan, ruler, princess, throne, royal. And again, these are our cosine similarity values, right? So if I want to make sure that these are, how do I know that these are cosine similarity values? So this is actually how the similarity scores are measured for Word2Vec model, right? So in order to verify that, what you can do, you can import from sklearn dot matrix, okay, dot, there is something called as pairwise. You can import cosine similarity, okay. And now what I can do, I have this vector, right? Now I want to check the similarity of this vector with the vector queen, right? So what I can do cosine similarity. So it has to be list of iterables or array of iterables. So that's why I'm enclosing it within a pair of square brackets so that it will be list of lists. Okay, list of list. Then model of queen, right? This model of queen will give me the vector for queen, right? As we have seen here. So for king, it gave me the vector for king. Similarly, for queen, it will also give me the vector for queen. Now, if I execute it, okay, so it says some error. Make sure we actually convert it to numeric. Okay, it says expected 2D array got 1D array. Oh, okay. So what I forgot here, I forgot to enclose this in a set of square brackets so that it will be a 2D array now. Now, if I execute it, you will see the cosine similarity between the vector that we obtained using this formula, king minus man plus woman, and the similarity score we compared for that vector with the word queen, and it gave us 0.5354. So now if you check this 0.5354, this is the same similarity score with respect to queen, right? When we compare the vector that is obtained using this equation and compare that vector similarity score with the queen's similarity score, we got 0.5354, which is matching here. So we are sure that these numbers are our cosine similarities, right? So this is how you make use of pre-trained Word2Vec model. Okay. Now let's see how we can train our own Word2Vec model on our data set. Okay. So let me just write it. Word2Vec model on our own data set. Right. So for this, I will be making use of a data set which consists of reviews from Amazon for clothing, shoes, and jewelry products, right? So this is available in the form of JSON, and I will also give you the link for the data set. It has multiple data sets for Amazon product reviews categorized into multiple products. Okay, so this is just one of those categories: clothing, shoes, and jewelry, right? So I will be using this JSON data to train my Word2Vec model. Okay, so first for that I'll have to import that JSON, right? I'll have to read that JSON. So how do I do that? For that, I'll need to import pandas as PD, okay? And then I will read the data. df is equal to pd dot read JSON, right? And then I'll need to supply that file name, clothing, shoes, and jewelry.json. Now there is a parameter lines is equal to true in order to read the JSON files, right? In order to understand what this lines equal to true means, you can go to shift tab and then expand it and you can read it here, right? This video is concentrating on how to train our Word2Vec, so I will not dive deep into that particular parameter. All right, so let's proceed. So now that I am reading the file, it's a big file actually, right? So it may take a while to read it. Okay, we have it. So let's check how the data looks like. If I say df.head, okay, so it has around 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, and head displays 5 rows, right? So let me check the overall shape of this. Okay, so it has around 278,000 reviews. Okay, so it's huge and it has 9 columns. We will be interested in this particular column called as review text. Okay, so we will see what those review texts are actually. So if I say df of review text, it will give me a series, and if I just want to check the first one, let me just read it out. So it says, this is a great tutu and at a really great price. It doesn't look cheap at all. I'm so glad I looked on Amazon and found such an affordable tutu that isn't made poorly. So A++, maybe this guy is giving a rating to this particular product. He or she bought that. Okay, so that's what the review text are. Okay, so now you can see it has mixture of capital letters and small letters, and also it has some punctuations, right? We will have to pre-process the data. So in order to do that, Gensim provides us with a utility called as simple pre-process. So how we can make use of that? From gensim.utils import simple pre-process, right? Simple pre-process. So now I import it. I will show you what this actually does, right? So simple pre-process, and it accepts the text as input, right? So doc, convert a document in, it accepts doc as input, and it converts the document into a list of lowercase tokens, ignoring the tokens that are too short or too long, right? And how this is determined, whether it's too short or too long, it's based on the min length and max length. So if a token is only a character, it will ignore it. If the token is having more than 15 characters, it will ignore it. So that's how the pre-processing works on simple pre-process method. So let me just supply this, okay, and see the output. Okay, so you can see everything is converted to small letters, and if we see, do we see any punctuations here? No, right? So isn't, it's removed, right? And also there is no punctuation between I am here, right? And that's completely removed. So after removing it, it's just I and am. So length is less than 2. It will just ignore it, right? So this is how the pre-processing is done with the help of simple pre-process. Now what we will do, we will apply this simple pre-process on entire column, review text column. Okay, so how we can do that? It's simple. So we can say df of review text dot apply. So what we have to apply on that particular series, we have to apply simple pre-process. Simple pre-process, and this will return us the series, right, with the reviews converted in this particular fashion. Okay, so let's execute this. So this may take a while also. Let's see how much time it will take. Okay, let's wait for a few seconds. Okay, so it's now complete. It hardly took around 40 seconds. I had paused my video for that duration, so it won't take that long. Okay, so now that we have pre-processed the reviews, let's see how they look like. You see, so this is a type of series, pandas series, and each of the reviews is converted into tokens, word tokenization, and then the punctuations are removed. Two small words or individual characters represented as words have been removed, and any word with length greater than 15 have been removed. Okay, so this is how you pre-process it. Now we will train the Word2Vec model on this particular dataset alone. We will not make use of pre-trained Word2Vec model from Google. So how do we do that? So for that, we will have to initialize the model, right? So for that, I'll say Word2Vec model is equal to Word2Vec, and this also takes some parameters, right? So sentences, corpus. So for the sake of initialization, let me say min let's say min count. Okay, yeah, that's min count is equal to 2. So what this min count is, so while training the model or while creating the embeddings or embedding matrix, it will consider only those words which have at least occurred twice. Which have occurred only once, it will not be considered, it will be dropped from the vocabulary. Okay, now, and to speed up the process, let me pass in another parameter called as workers. I'll say 5 because I have total 8 cores available with me. I do not want to use up everything, so I'll ask it to use 5 cores. So this workers, it should be workers. Okay, so now I have initialized the model, I have not trained it yet, right? Before training, we will have to supply the vocabulary to the model. So how we can do that? It's model dot build vocab. Okay, and how do we build the vocabs? We will build using this reviews which we got after pre-processing. How? Using simple pre-process method, right? So I'll supply reviews, I'll just execute it. This will also take a while because it's huge. There are total 278,000 reviews available. And regarding the link, till the time it gets created, the vocabulary gets built. Let me show you the link where I got the data sets here. Okay, so it's here. So it has already built the vocabulary, but nonetheless, so this is the link. I will put it in the description. You can get any data set from this link you want. So you just click on these blue links here, you will have that file downloaded. Okay. Now, so since we have built the vocabulary, we are ready to train the model. But before that, let's see what information the model has based on the vocabulary that is built. So let's say model dot, so let's see corpus count. So how many it has? Okay, so it says 278,000. That's wonderful because it's matching the number of reviews that we had, right? And for how many epochs the model will be trained, that also we can see model dot epochs, it's 5. So for 5 epochs our model will be trained. And how do we train the model? Now we are ready to train the model, right? So how do we train it? So it's simple. We will say model dot train, and you will train it on reviews, right? You will train it on the reviews that is pre-processed using Gensim methods, right? So we will pass that reviews, and we will say total. We have to pass some parameters. Total examples, it will be equal to the corpus count. So I'll just say model dot corpus count. So these are our total trainable examples. And epochs, it will be default model epochs, which is 5. You can either give 5 or you can give any number you desire. Okay, it will be trained on those many number of epochs. So let me just train it. It will take a while. I'll pause this video for a while till the training gets completed. Okay, so let's see how much time it takes. I'll update you guys. Okay, so it took a minute to train the model on this much corpus. Okay, so now let's see the results. Okay, so model. So if I want to check some embeddings for the words, since it is the text is of reviews on the products, we'll see if there is any word embedding for good. Okay, so this is the word embedding learned for the word good. and this is of size 100 dimension. So by default, Word2Vec gives us 100 dimensional vector space for each of the words, but the Google pre-trained model is of 300 dimensional vector space for each word. Okay, so remember that. And you can change this. You can, while initializing, you can, I think you can supply the size here, right? So this is 100. You can change it, size to 200, 300, 400, 500 of your desire. So those many length vector for each word will be computed. So now it's default 100 dimensional vector. If you change it to 300, size equal to 300 by initialization, it will give you 300 dimensional vector for each of the words. Okay. Now let's see if it is doing any good on fetching the similar words, or has it understood any of the available context around it. So for that, let's say model dot most similar, and let me see most similar for good only. Let's see for good. Okay, so it's not subscriptable. We have to pass in it as a parameter. Okay, so let me just type it good. Okay, so it's not bad. For the word good, it's giving great as a top similar word with similarity score of 0.87, which is really good. Decent, nice, fantastic, excellent, terrific, wonderful, awesome, amazing, superb. So this is really working good, guys. With just 5 epochs, the model is really doing good. So let's not jump to conclusion. Let's check for some other words. Model dot most similar, and this time let me check for some cheap, describing it's not good or something like that. Okay, so it's good. Cheap, flimsy, tacky, cheesy, fake, shabby, cheapy, fragile, okay, expensive. So this model is really doing good with what we have done so far. So it's just with 5 epochs, it's doing great. If you increase the epochs, it may really do good. I mean, it's already doing good. I don't know if you guys want it to improve further. You can try it out. Okay. So you can try to increase the dimensionality, you can try to increase the number of epochs the model has for training. You can do all those stuffs and test it out, how the model is working. So that's it for this video, guys. So in this video, we have seen how to make use of pre-trained Word2Vec model by Google, right? And also we have seen how to train our own Word2Vec model on the dataset that we have. So if you want, you can take one thing as an assignment, pick any dataset here, right? Pick any of the dataset and do train your own Word2Vec model and comment it out in the comment sections how it is performed, and also you can comment out the approach, how you trained it, or if you guys have tried any other methods or any other pre-processing steps, or if you use any new parameters within the available functionalities, you can state it out. Okay, so till we see in the next video, guys, happy learning, stay tuned, bye bye.